Hello and welcome everyone to the Data, Database and Analytics online series. My name is Olivier Klein and I'm the lead technologist for Asia Pacific in AWS. Today and also tomorrow, we kind of have an action-packed agenda to talk about data, database and analytics and also machine learning. And today's keynote, we're going to focus a lot on how we build databases, purpose-built databases, build data lakes, kind of data movement, and have a quick look at analytics. And then tomorrow we're going to have another keynote and also breakout tracks that focus a lot more into how do we do predictive analytics and machine learning and go a little bit deeper into some of these analytics services that we have to offer. Now, apart from the two keynotes, there are also 3 different breakout tracks today and 2 different breakout tracks tomorrow. So please have a look at those and choose the one that are appropriate for you or of interest for yourself. Now, please also note, this is an actual live keynote, so we're actually streaming this out, currently based here in Hong Kong. So you see me here from Causeway Bay in Hong Kong. What is important though is, because it is live, you can actually ask me any questions. We have a team on the line in the viewer panel that you right now have. You can actually ask questions and the team will forward them to me. I'm going to try to address those later. So super happy to answer any of the questions, so feel free to test me. Now, before jumping in though, why do we actually run this online series? Data, databases, analytics, why do we do that? Well, if you think about it, we have an explosion of data that happened over the past and it keeps accelerating. The old traditional ways of maybe storing data in just simple relational databases doesn't quite cut it anymore. We have an explosion of data, structured, unstructured, semi-structured, that comes in at a very high velocity. So that kind of traditional database doesn't quite work anymore for all the different data that is streaming in from third parties and social media and your platform and maybe your IoT sensors and telemetry that you have around it. So what we first want to look at is how can we actually break free from some of these legacy databases so that we can store data a lot more effectively and actually can get better insights no matter how much volume or velocity that data has. Now, as we start doing that, the next obvious thing is how can we reduce some of the heavy lifting of actually maintaining and running those databases, scale them out? And how do we do that? Well, we want to move to fully managed kind of services in a cloud computing environment, specifically AWS here for today. That will save us time and cost that we can reinvest into them potentially modernizing the way we store data so that we can get better insights. We want to look at how can we modernize our data warehouse? How can we maybe create data lake strategies so that we can answer different queries for our business or get insights for our business faster and with more data points from various different providers or our own platforms and data that we're collecting. And talking about data collection, well, as we start modernizing our data warehouse, we can think about how can we actually build applications or platforms that are much more data-driven. Now, as we now started moving applications to a cloud computing environment, it will make it easy for us to be fairly agile in the way we develop applications. Think about, CI/CD pipelines, microservices that we can build out, or overall being more agile and building applications for a global user base. With a click of a button, I can go global with the AWS regions all across the world. In addition to that, we also have a look at how do we make sure that our application perform at scale. And you'll see that databases play a big part here, and we want to use purpose-built databases for the right kind of use case that we're building out in applications. Key point though is we don't need to be afraid anymore to collect lots of amounts of data because we modernize our data warehouse so that we can scale for any kind of data volume. Which brings us to the point that we now can get better and faster insights if we set ourselves up correctly with this new data lake and modern data warehouse approach. And why do we do all of that? Well, so that we can get better and more insights and actually create better experiences for our customers. Think about personalization, or think about things like forecasting effectively so that you run your business more effectively, or overall understand the feedback from your customers or consumers a little bit better, or maybe run your processes more efficient. Now you can do that because you get more insights from your own data platforms and from third-party data platforms, which allows you to build and not be afraid to build more data-driven apps, which will in effect generate more data, which then will activate the data flywheel, which out of these new data points, you can again get more insights on what's going on and build better experiences for your end customer. Now, that's kind of the overall overview. We talk a lot about data, so let's start with the core of it. If we build an application, we very often, if not always, require some form of database to store information and retrieve and query information back. Now, traditionally, it was totally okay to kind of just use the default relational database, your MySQL or Oracle database or SQL Server, what have you, and that worked. But in the new world where we have tremendous amount of volume, tremendous amount of users, and a fast pace and scale, we kind of can't really rely on just building on relational databases anymore. And why is that? If we think about the way we build applications in the past, we might have been running on a mainframe, then eventually we moved to the client-server model, then we moved to kind of the three-tier architecture model, and lately we moved to this kind of service-oriented or microservice architecture. Why do we actually do that? Well, so that we can gain agility, right? Take your platform or business and break it down into its individual functionalities, create teams that independently work on those functionalities, very often referred to as microservices, so that they can iterate quickly, but most importantly also, that they can choose the right technology and specifically the right purpose-built database for the microservice that they are building. And why is that? Well, if you think about it, these new modern applications and platforms that we're building nowadays, they have completely different requirements than what we had in the past. Millions of users is default. Global user base is default. We talk about terabytes, petabytes, exabytes potentially that we need to store. And then we need to retrieve them with a performance of milli to microseconds at times, right? And relational databases might be great for certain use cases, but don't quite always scale to maybe a request rates of millions per second or queries per second here. Now you can scale them out, but it will be tricky. So if we think about these new requirements, what should we do? Well, what we can do is because we build on the microservice concept, we can think about for the use case or the functionality that we're building, let's try and find the right kind of data store, the right kind of database for that use case that we're building. So let me go through a few here to kind of understand what are the access patterns and how do we make these choices. Now I keep mentioning relational database. Now relational databases are not there to go away. They make a lot of sense when we need relations, referential integrity, asset transactions. Think about a CRM system, an ERP system, or a finance system. A relational database will just be fine for that. But what if we have a higher kind of throughput that goes to the database and we need a lower latency, millions of requests that suddenly stream in, millions of writes that we need to write? Think things like, in the advertisement space, real-time ad bidding. Latency is important, and we have potentially millions of these requests and writes that are coming in. Think about a shopping cart in an e-commerce experience. Think about social media. Think about product catalogs or customer preferences. This is very often where we want to have some form of key value, kind of NoSQL database, because we can scale for these kind of scenarios. Similarly, what if we have the scenario where we want to store large amounts of data with virtually unlimited scalability? That's where we want to choose a wide column kind of purpose-built database. Useful for scenarios such as industrial equipment that pushes a lot of data back. Scenarios where we do route or fleet optimizations. That's where wide column databases are useful. Now, what about scenarios where we don't quite know the schema up front and the schemas kind of will change for every input or every row, so to speak, that we're actually populating into our data store? That's very often where we want to use a document database. So we can store documents that we can quickly access and query its attributes within those documents that can change for every individual document that we store inside there. Very useful for scenarios such as content management or personalization kind of scenarios or mobile application kind of scenarios. But what if we have an access pattern where we want to query by key with microsecond latency? Think about scenarios such as, online sessions that you have on your platform. Think about things like leaderboards in online multiplayer games, right? Latency matters a lot here. Think about geospatial services or real-time analytics. That's where we want to look into an in-memory database because it will provide us this microsecond latency that we need to have for those kind of use cases. And what about if we want to query data, but we want to understand the relationships between those data points that we store, and we want to quickly query it or easy and simply query it with a query that allows us to explain these relations? that is where we often look for a graph database. Think about scenarios such as, obviously, social networking, recommendation engines, or even fraud detection. If you do fraud detection, very often you want to understand the relationships to understand, was it fraudulent transaction or was it not? That's where we require a graph database. If we have scenarios, especially with IoT and sensors and telemetry data that's streaming in, where we want to understand how data changes over a period of time, so time is the key component, that's when we generally want to use a time series database, so it's easier for us to query and analyze the data points, how they change over time. And lastly, in certain use cases where we need a system of records, think about the financial service industry, where we have systems of records that we cannot change, or any change must be documented and auditable, where we need a complete, immutable, and verifiable history of those data points that we're storing. That's generally where we want to have a ledger database. So we're breaking free from just choosing one database by thinking about, depending on my use case, what's the right purpose-built database. The next step now is can I move to fully managed? I don't want to bother about scaling, these databases out. Think about that key value example, at a very low latency with millions and millions of requests. That could be painful if I need to build it myself. So this is where I want to use some of these fully managed AWS services, specifically in the relational database space, would be Amazon RDS. We take care of patching, maintaining, backing up your data, and you can choose your engine. You want community editions of MySQL, PostgreSQL, or MariaDB, or you need Oracle DB or Microsoft SQL Server, or you can use Amazon Aurora, which is an even more scalable relational database that's compatible with both MySQL or PostgreSQL. If I want to have a key value store, the Amazon DynamoDB can help me here. If I need wide column, Amazon Key Spaces, that gives us compatibility with Cassandra. So if you're using Cassandra, Amazon Key Spaces is what you actually want to look for. Amazon Document DB for documents, of course, again, comes with MongoDB compatibility. So if you have MongoDB, that's probably one of what you want to look for. And then Amazon Elasticache for in-memory. Again, comes with two engines, both Redis and Memcached. So depending what you use here, Amazon Elasticache fully managed. Amazon Neptune for graph, Amazon Time Stream for time series, and Amazon Quantum Ledger Database, QLDB, for your ledger kind of use cases. And you can find that lots of our customers are using these purpose-built databases fully managed on top of our platform because it provides them with tremendous benefits of not needing to maintain and scale it and rather focus on building their business. Take, for example, Lyft, a ride-sharing service. Obviously we have situations where we have cars driving around with riders, and then we have people that want to be picked up. So GPS locations need to be accurate and constantly populated for every single ride. That's a scenario where we need to, or where a key value kind of purpose-built database would be useful. So they are using Amazon DynamoDB for their ride tracking system, where the GPS coordinates are stored in there for every single ride. In a similar gist, Nike is looking into how can I give better, more personalized experience to my end consumers. And they actually store millions of relationships among their users and their preferences. And again, this is a certain scenario where we talk relationships between user preferences, personalization. That's probably where graph database is useful. They are using Amazon Neptune to store these millions of relationships. And so ideally, when we build an application or build our microservices out, we can choose this best purpose-built database straight from the start. However, we probably already have an existing business, and with that comes applications or certain legacy applications that we have, potentially on-premise or maybe already in our AWS environment, but in a maybe traditional relational database. So what can we do? Well, we got to think about how can we maybe migrate some of that legacy over. AWS Database Migration Service, or in short DMS, can actually help you to migrate your databases from on-premise onto AWS seamlessly with near zero downtime. But at the same time, you can also break free from maybe some of these databases that you currently have and say, I want to move to a more purpose-built database, or I want to take one of the commercial databases and move to open source. Well, Database Migration Service allows us to migrate between databases thanks to the automated schema conversion that comes with it. And like I said, the data is replicated continuously, so you can actually have a near zero downtime scenario where as it starts replicating, you wait for it to be completely replicated, and then you flip the switch before you move it over. And this has proven really popular for our end customers. We actually have over 200,000 databases that already have been migrated using the database migration service. And talking a little bit about migration, let me give you an example of one of our customers, and this might sound funny, but Amazon.com is a customer of AWS. Now, Amazon.com and the entire retail space has a plethora of different platforms. Think Amazon Advertising, Prime Video, the fulfillment centers, etc. Lots of data that's being stored. And traditionally, we had that running on Oracle databases. To be specific, it was 75 petabytes worth of data that was stored in 7,500 different Oracle databases. Now, these numbers are mind-boggling if you think about it, which obviously resulted in a lot of complexity to actually scale those databases out. And to add to it, given the punitive Oracle licensing, it was actually really expensive to do so. So the team and the retail department here actually looked into how can we move, not only break free from some of these commercial databases to move to purpose-built databases and open source purpose-built databases, but also move to fully managed. So they decided, can we move that to Amazon Aurora, Amazon RDS, Amazon DynamoDB, Amazon Elasticache, and Amazon Redshift for data warehousing. Now, after that migration, not only did we have a 60% reduction in database cost, we had a 70% reduction in the administrative overhead that we had to maintain those databases, because they're now fully managed. And for the better of it, apart from saving a lot of money, well, we actually had a 40% increase in performance in the most critical applications. And this is really why you want to rethink what you currently have. Can I migrate, to certain data stores, purpose-built databases, and to fully managed? The benefits are just tremendous. So I talked a lot about databases, but this online series here is also about, analytics and actually turning data into insights. And databases are maybe the key point, a starting point, but we want to expand that. Now, the landscape here is a little bit more complex. So what I want to start doing here first is kind of draw out the overarching architecture of the different components and initial services that we probably want to use if we want to build the right kind of landscape to set ourselves up for success. As I'm an architect, what's the best place to do that? Well, we're actually going to try to draw it out here on a digital kind of whiteboard. So let me flip over here. I'm just going to take my pen. So we talked about databases. So let's start with that. So you obviously have the different purpose-built databases. So that might be relational, think RDS. But that might be any of the other purpose-built databases. Let's say I have a graph database here, Neptune. That's kind of what we're starting off, right? These our applications are writing into these databases. Now, should we query all of these databases straight from our analytics services? Yes, we could, but that's probably not the way we want to operate it. So the better way to do it is, we probably want to come up with some form of a data lake, which means we decouple compute and storage. So we independently store it in a storage service so that we can scale to virtually unlimited amounts of data fairly cost effectively, and then only run analytics services on top of it when we require. But to also make sure that we kind of understand what we're doing here, we also want to catalog that data and provide access to end users of the different business units to make sense of it. Now, if we talk data lake, the first thing that's important is storage. Now, if you're familiar with AWS, you probably know Amazon S3, which is probably the storage service that we want to use. But you should also consider scenarios where the Elastic File System might make sense, and scenarios where FSx for Lustre or Windows File Server will be quite interesting, especially for HPC kind of scenarios. At the same time, for data cataloging, AWS Glue, and I'm going to explain a little bit more about that service later, will help us with crawling the data and cataloging it out properly. So that's great. So now we have that kind of data lake and cataloging. We want to see how we can move some of that information from the database continuously into that data lake, and we're going to have a look at that. Now you're going to say, okay, great, but you talked about legacy. You talked about things that I have on-premise, right? So how does that now fit in here? Well, as I already mentioned, the database migration service, actually let me switch here my color over so we keep it consistent. the database migration service here will help us to potentially migrate some of these databases over into fully managed databases. But at the same time, we might retain some of the things on-premise. This is where the AWS Data Sync service can come in handy, so we can synchronize data over. We also have the ability to use AWS Outposts to actually run the same hardware that we use for AWS within your an on-premise environment, and we're going to get to that. And that can be useful for this kind of hybrid analytics cloud experiences. So actually, there you go, touch the wrong button here. Or scenarios such as storage gateway that allows us to potentially store things on-premise and have them slowly replicated over into our data lake. And like I said, database migration service will also allow us to migrate it over properly here. Okay, great. But how about data sources? Now you say, okay, data sources could be the databases here, but there could be external data sources. So let's try to draw these out too. So let's talk about data sources. So, excuse me, I'm not drawing properly here today. The first data sources are obvious. Think about your applications and microservices. They're obviously generating data, so that might be one of the data sources. But what about third-party data? Well, sometimes you want to mix and match information that you have for yourselves, but also data points that come from other third parties. The AWS Data Exchange service can help with that. We're going to talk about that a little bit more in just a bit. But at the same time, we might also have sensor data that streams in via AWS IoT or other services, or think about social media that we might connect to it. So these are all data sources that we should consider when we collect information into our data lake and catalog it out there. The next thing, obviously, now we want to get insights. So let's talk analytics here for a second. Well, again here, there are a variety of fully managed analytics services, and I'm going to talk about them in just a little bit. Services such as Amazon EMR, which allows me to run my Spark or Presto or HBase fully managed on top of AWS. Amazon Redshift, if I need to have data warehousing capabilities, and my pen leaning wrongly over here. Or Amazon Athena, that allows us to run complete interactive queries completely serverlessly on top of my data lake. And I'll draw this arrow bidirectionally because we obviously might, clean some of the data, move it back into my data lake or data puddles that I'm creating out of that. Then lastly, we get into the space of visualizing that data, but also looking into, can we do predictive analytics? So think about AI and machine learning as such. What do we have here? Well, for machine learning, we probably want to have a look into Amazon SageMaker. But you should also have a look at the fully managed AI services that we provide, such as Amazon Personalize or Amazon Forecast, where you get access to the same personalization or recommendation models that Amazon.com is using with your own data within your data lake. And then if we want to visualize it, we probably should have a look at QuickSight or any of the business intelligence tool that you find in the AWS Marketplace. We can obviously connect those again with our analytics services and can also load up some information and write it back into our data lake. And lastly, very important, if we now take that full view here, across all of this, we then also need to make sure that we secure this and that we put the right kind of data governance on top of it. And there are plentiful, there we go, governance on top of it. And there are plentiful of different AWS services that can help us do that across that board, no matter if it's on-premise within your environment, the data lake, all the way to other external data sources. So let's try to run through this in a little bit more detail. So let's go back to my slides here. Let's start first off with, well, how do we actually move data? Before we start, designing our data lake, we should think about, we probably have data on-premise or what have you. How do we move that over, right? I drew out that on-premise component. So let's try to understand that a little bit better. how do we actually move data over? Well, there are a variety of different services that can help to move it from your on-premise data centers or even do data movement for real-time data sources that you currently have. When we think about on-premise data centers, first and foremost, there's services such as Amazon Direct Connect that would allow me to have a dedicated network connection between your edge sites or on-premises straight into AWS. Then there are a variety of services and secure appliances that allow you to synchronize data over, and we're going to talk about those in just a little bit. And sometimes if the network connectivity wouldn't be fast enough for the vast amount of data that we're trying to move over, we can actually use ruggedized shipping containers, part of the Snow family, which I'm going to describe in just a little bit. And what if it's real-time data? Well, there are a variety of different services, such as the Amazon Kinesis family, that allows us to do real-time data streams or video streams that we stream and migrate and move over into our data lake environment within AWS. But let's step through some of those. Let's say, for example, AWS Data Sync. AWS Data Sync is a great service that allows us to do online automated replication, accelerating data of synchronizing it online between your on-premise to your AWS environment. So it's an AWS Data Sync agent that generally runs or is deployed on VMware, and it can take your shared file system, think NFS or SMB, etc., and actually synchronize that data over to Amazon S3 or your Amazon Elastic file system or your FSx for Windows file server. So that's great for that kind of online kind of synchronization and data movement. But what if we have such large amounts of data that network connectivity, meaning online, just doesn't quite cut it? Because if we talk petabytes and petabytes worth of it and we have a smaller kind of network connectivity, it might take years to move data over. Well, so we came up with the idea, could we actually physically ship data? But when we physically ship data, we want to make sure that it is secured. That's where the AWS Snow family comes in. And there are three kind of options here: the AWS Snow Cone, the AWS Snowball Edge Storage and Edge Optimized, and the AWS Snowmobile. AWS Snow Cone is the newest here in this family. It's a smaller kind of ruggedized appliance. Ruggedized appliance meaning, feel free to throw it on the ground. It will hold it to it, and it can store up to 8 terabytes. We ship it to you, you load your data up, and you ship it back to AWS, and we load it up in your the dedicated Amazon S3 bucket that you want to have as target here. What if you need more data? Well, 80 terabytes, up to 80 terabytes, you can store on an AWS Snowball Edge Storage Optimized. But it gets better. You can actually cluster them together, and if they're clustered, you can move up to a variety of petabytes worth of data, and that's a lot of data that you can ship easily within days or weeks back into AWS. And when you say, I really have a lot of data, well, that's where AWS Snowmobile comes in. A truck that actually pulls up next to your data center and then physically allows you to move up to 100 petabytes worth of data within weeks straight into AWS. So that's a great way. But then I mentioned, what about if you want a certain hybrid experience? What if you, still want to have certain things on premise, but you want to have the kind of same kind of tools, APIs, and the single management pane between AWS and your on-premise data center? Well, this is really where AWS Outposts comes in. It helps you to bring that AWS experience onto your own premises. So you have an industrial standard 42U rack that's fully assembled, ready to be rolled into position within your facilities, and that is the same AWS designed infrastructure that we are using, that you now have on your own premises, and it's built on top of that AWS Nitro system. The best part, it's fully managed, monitored, and operated by AWS and connected to your AWS region, so you get that single pane of management, the same APIs and tools that you use in your cloud environment now on premise. And that then comes with a variety of services, such as, for example, Amazon EMR. We're going to talk about Amazon EMR a little bit more in just a bit, but it allows us to run, things in the Hadoop ecosystem. Think Hive, Presto, Spark, etc. Well, what I can do now, Amazon EMR allows me to run these fully managed in my cloud environment within AWS, but I can also run it on my AWS Outpost, deploy them securely and fully managed onto your own premises in AWS Outpost. Gives you that consistent, seamless, hybrid cloud analytics experience with AWS Outposts and Amazon EMR. And it gets better, because if you have existing on-premise Hadoop deployments, you can now integrate these together. All right, great. So we talked a bit about data movement and edge and on-premise here. So now let's talk about when we move data, where do we actually bring it to? Now, do we just put it into A data warehouse appliance, traditionally we had like these big data warehouse appliances, storage and compute tightly coupled together. That doesn't quite work for those large amounts of data that we're talking about here. So we rather want to get into a concept of data lakes. And you actually find that plentiful of customers are making use of AWS to build their data lakes on top of us and our different analytics services. Think McDonald's, Dow Jones, Pfizer, Netflix, 3M, Airbnb, Barclays, Amazon, Adobe. All of these companies have chosen us to build their data lake on top of us. But when I say data lake, what do I actually mean with that? Well, like I said earlier, traditionally we have these kind of data warehouses where we load up data from our OLTP databases, our relational database, ERP, CM, lines of business databases, move them into that data warehouse. And these data warehouses are often siloed between the different kind of business units. And what that means is, we build intelligence around it, but we don't get the full view across our entire company or platform because we silo these things out. And these data warehouses don't scale really well. So what we rather want to do is, we want to build data lakes, decouple compute and storage, build on top of open formats, allowing us to store semi-structured, unstructured, and structured data, and centrally catalog it so that we enable users to be able to actually make use of that data, and then build a plethora of services or analytics services around it, BI services or analytics services around it, or even machine learning capabilities. Now that sounds great, but how do we build such a data lake? I mentioned, you want to decouple compute and storage. So storage, as I drew out earlier, that kind of sounds like Amazon S3. So is it as simple as just opening up an Amazon S3 bucket and you're done with your lake? Not quite, because a data lake should be more than that. It should take permissions into account, users, how they access it. It should take cataloging into account. Now, if you want to set that up, there are a variety of different services that can help you do that. However, instead of building it all yourself from scratch again, we kind of thought about it and say, could we make this easier for our customers? And so we launched a service not too long ago called AWS Lake Formation that allows you to build your data lake securely within days. It comes with that entire cataloging platform so you can discover and share your kind of data that enables any kind of end user to kind of work with that data and get the insights out of it. But then if you think about it, should every user have access to all of your data? Probably not. So it also comes with that centralized management capability to allow any kind of security officers to create very fine-grained access permissions. What user is allowed to access what and what kind of level of data. Again, we then empower security officers to go in and define this. So it's all about enablement of people. At the same time, it obviously also comes with a simplified way of ingesting and cleaning data, and that's part of AWS Glue, which I'm going to talk about next. And since it's stored on Amazon S3, it's very cost-effective and durable storage. Amazon S3 comes with 11/9 of data durability, and if you so desire, also with global replication capabilities if you want to enable that. Now, I talked about AWS Glue. What's AWS Glue? Well, it allows us to catalog our data, but also transform, massage it using simple and cost-effective serverless ETL kind of jobs within AWS Glue. So it's split up between the data catalog, so it creates that data catalog for you. And by the way, if you have existing kind of Hadoop deployments, you're likely probably using Apache Hive metastores to probably catalog your data. Well, it's compatible with that, so that's great. And it integrates into a lot of AWS analytics services that we're going to talk about later. It also comes with data crawlers. So you point to different data locations. AWS Glue starts to crawl that data, automatically tries to infer schemas, and then populates your data catalog. This is really important because very often we have lots of different data sources, and it might not be known to us what the schemas are, and we don't not quite know if we want to how we populate into the data catalog. So the crawler is a great way to get started that way. After crawling it out, populating a data catalog, you probably decide to massage some of that data. So perform certain kind of ETL, ETL kind of processes, excuse me. And this generally we do probably with some Python scripts or Apache Spark kind of different kind of jobs. Well, with AWS Glue, you get those serverlessly, right? So you can set up these transformation jobs, you actually have a console to do it, and then you can say how and when it runs, which brings me to this kind of flexible workflows. You can decide if it's maybe a schedule when you run that ETL, or it can be actually triggered to certain events. Because within AWS, you can build event-driven architectures, and as such, you can also use AWS Glue to build an event-driven kind of ETL process here. All right, great. So we talked about data movement. We talked about how to build your data layout. We talked about on-premise and all of that stuff. What's the next thing? We actually want to now gain insights with what we have built so far. So let's talk a little bit about the actual analytics services. So as we now have built the entire data lake on top of AWS, we want to kind of gain insights on top of it. And again here, similar to when I talked about databases earlier, we want to choose the right service, the right tool for the job that we're doing. So if you need data warehousing capability, it might be Amazon Redshift, which helps you here. If you need this kind of big data processing capabilities, think about the entire Hadoop ecosystem, Spark, Hive, Presto, etc., HBase. Amazon EMR is a fully managed service for this. If you want to do it serverlessly, run a SQL query on top of flat file data on S3. That's where probably Amazon Athena comes in quite handy. Operational analytics, Amazon Elasticsearch Service, fully managed Elasticsearch Service, as the name indicates. What if I want to bring in third-party data and mix and match it with the queries that I'm